Hey everyone, welcome back. In this video, we are solving the FRQ from 2023, question number 4B, which has to do with concavity. Take a second to pause this video, read through the question, take a look at the graph, and then meet me back here for the problem solve. Okay, so this question asks us on what open interval, if any, is the graph of f concave down? Give a reason for your answer. Okay, so the first thing we have to know, of course, is what does concave down mean? So visually, if we have the graph of f, concavity I like to think of as looking like a bowl. So this would be an example visually of what concave up looks like. And then if we had the graph of f that looks like this is what concave down would look like. So I literally think about holding a bowl in my hand and I think, okay, well, am I holding the bowl up or am I holding the bowl down? What makes this question a little different is that we don't have the graph of f, we have the graph of f prime. So you will hear me say this frequently, but it is really, really important to read the titles of your graphs. That's why you always want to make sure that you recognize here that this is the graph of f prime and not the graph of f, because if you thought it was, that's a really easy mistake to make, and then you probably would get this question incorrect. So now let's talk about what concavity means in terms of the derivative and the second derivative. Really specifically, I mean the second derivative. So in order to find if a graph is concave up, we would take the second derivative, so we would take f double prime, and we would check if that's greater than 0. If it's greater than 0, that tells you that it is concave up. If instead we took the second derivative and we found that it is less than 0, that would tell us our graph is concave down. Now we have to think about how the graph of f prime relates to our second derivative. Well, to go from f prime to f double prime, we would have to take the derivative, right? And remember, derivative represents slope. So if we are looking for where f double prime of x is less than 0, because it's asking us, right, where f is concave down, what we are looking for is where the graph of f prime has a negative slope, right? Because that means it has a negative derivative, which would tell us that the second derivative is less than 0. So let's go ahead and just take a look and look everywhere that our slope is negative, right? So everywhere here, this is all negative. I like to think of just if I'm going left to right, if I'm like skiing or something, right? Am I going uphill or downhill? Or if I'm hiking, right? Here I would be hiking downhill. Here we have this positive slope, but again, at 4, it turns negative all the way to 6, right? So those are my intervals on the graph where my slope of f prime is negative, which tells me f double prime is less than 0, which tells me f is concave down. I know I'm repeating that a lot, but it's a lot of different concepts to kind of tie together, and they're all very important. So now what we would say is f is concave down on, this would be -2 to 0, and the interval here from 4 to 6. So 4 to 6. And then, of course, we have to give a reason. And we could say because, sorry, I just kind of ran out of space here, but let me just do it up here. So because the slope of f prime is less than 0, like on those intervals, we could just say on those intervals. Okay, great. Awesome. So thanks so much for watching. Hope this video was helpful. If so, I would love to hear from you in the comments below, and I will see you in the next one.